A very good morning. During second cycle experiments in BW lab, we have some experiments on equipments, motors, generators and transformers. So as far as transformer is concerned, we have two experiments to perform on single phase transformer. I would like to give a small description about the construction of the transformer. Basically, a transformer is consisting of primary coil and secondary coil. So this is the panel board. All wiring can be done outside of this, and the actual transformer is erected inside of this panel board. And here the primary turns and secondary turns, you can see number of turns at primary side is more, number of turns at secondary side is less. So we can understand as this particular transformer is rated for 230 by 115. Basically it is a step down transformer. So we have two varieties of transformers in single phase. So that is step down transformer and step up transformer. We can discriminate the turns ratio between primary and secondary. So secondary low voltage is there, so the voltage at the turns will be very less, and primary side we have high voltage, that is 230 volts, so the turns will be high. So what is the working principle of a single phase transformer? Basically I would like to explain with the teaching aids which is made for the students better understanding about the working principle of the transformer. We have two coils, as I have already explained you, there are two coils. One is primary coil, the other one is secondary coil. So primary coil, nothing but these are the conductors wound on this bobbin, and we have two input terminals which is connected to power supply, and the other also it is the turns conductors, and two terminals are there. So this represents the secondary coil and this will represent the primary coil. We don't have any connection between primary and secondary, any electrical connection between primary and secondary. So these two are apart from each other. So I will just like to explain the working principle of a transformer with the help of these teaching aids. So I will take touch cords. So one coil is connected to power supply. This is the input power supply. So 0 to 230 volts, single phase variac. So this will work. It is a fixed input voltage, and output will be the output across these two terminals will be the depends on the variation of this knob. So it is varying on the secondary side tappings to give the required set voltage by the knob. We can vary the voltage from 0 to 270 volts by using this. This can be also called a variac or single phase variac. So for that purpose I have initially connected this voltage supply to the voltmeter which is going to read 300 volts AC. And from this voltmeter, so I will connect to one of this coil, and which is considered as a primary coil of the transformer, and now it is connected. When I switch on the equipment and apply some voltage, say it is this particular coil can bear up to 12 volts only, so I will apply 12 volts. So everyone knows that the current is flowing through the conductors. Every current carrying conductor will produce the flux. So there is an existence of flux that can be known by placing iron core. This is the iron which is attracted by the flux. So if you keep this iron piece into this section, you can experience there is a flux inside this. So now I will connect this single phase variable power supply to a voltmeter to see how much voltage is to be set. So here phase and neutral is connected. From this power supply I will connect to primary coil. There are two terminals provided for that. So there I am connecting the input power supply to the primary coil. Since the conductors of the primary coil is rated for 10 volts or 12 volts approximately, so I would like to apply only 12 volts to this primary coil, so that it is very easy to understand the working principle of a transformer. So here now it is connected to input supply. I will vary the power supply by seeing the voltmeter. So I will set the voltage of this power supply to approximately 12 volts, right, let it be. So now everyone knows that when current flowing through the conductor, it will produce the magnetic flux around it. You can see, so by keeping this iron into this gap, you can feel there is a flux inside it, since the flux produced by the current carrying conductor will tries to attract the iron piece. That you can listen. So here there is a noise. By this noise you can understand that there is a flux inside it and it tries to attract the iron piece like this. If I apply 100 volts, so definitely it is going to induce the voltage half of this input voltage, because the turns at secondary side will be less, d5 by dt rate will be less. So compared to input voltage, secondary voltage will be half. So this output voltage by input voltage will give you the transformation ratio in step down mode. We will conduct this experiment in two modes. Let us apply the rated voltage, which is 230 volts. So I have applied rated voltage. So depends on the construction of transformer, it will induce 115 volts. Same experiment can be repeated with step down mode. So I will remove all the connections. I will show just interchanging of the terminals. Now I will connect these input terminals to secondary side, and output voltage I will observe how much voltage is induced by secondary coil. So this is connected to voltmeter initially to read how much voltage is set. So everyone should be very careful while applying the voltage, because the rated voltage this side will be 115. It should not exceed more than 115. So now this is connected to secondary side. Previously we have connected to primary side. Now I have changed it to secondary side. Since two terminals are coming from input supply like this, so I am tapping from this and applying to secondary side, and primary side I will connect to this voltmeter. How much voltage is induced in the primary coil. So now input going to secondary coil, output we are measuring from this voltmeter. Input voltmeter is this. So now I will switch on. Remember, we should not exceed 115 this side, since the input voltage is going to this secondary side. So carefully I will apply the 115 volts. Which voltmeter you have to observe? This. So carefully you adjust the input voltage to 115. See that it should not exceed more than 115, because the rated voltage. So 115. You can see, but 115 can produce less flux, but it is interacting with more number of turns. That means d5 by dt will be more. So output voltage we are getting is more than the input supply. Input supply 115 applying to secondary coil and causes the voltage to induce in the primary coil to double of this, since the turns are more. This is transformation ratio experiment. Here what we do, output voltage by input voltage, that give you the transformation ratio. That is about transformation ratio experiment.